Alright guys, hope you're enjoying your snow day today. Today we were going to do this virtual lab on Kepler's third law. Since we're not going to have class today, you guys are going to do it at home. So remember that Kepler's third law relates the period of an orbit to this distance right here, A, the length of the semi-major axis. And you're going to do a lab today to explore that relationship, and then ultimately you're going to end up graphing your data so you end up with a straight line whose mass is equal to the slope of the Earth. So in order to do this lab, first thing you're going to do is control click on the link right here, and that's going to take you to a NASA website. Okay, and it's telling me that my Java is out of date, but it seems to be working with my old version, so I'm just going to accept the risk and go ahead and run. And you can see that this, if you click on this JTrack right here, that should bring up this Java application, which is trying to be weird for me now for some reason. Alright, so I am going to select a satellite, and the first one I'm going to select is this ACTS, A-C-T-S. Okay, then I can close that box, and then I am going to, if I click and drag, I can rotate this around so I can see its orbit better, and for some reason I've just switched satellites there. Let's try that again. Alright. There we go, and if I pull it where it's all red, that gives me the best view of the orbit. And then I need to zoom out a little bit, so I can go to view, zoom out. Alright, so right now it's showing the satellite moving at its actual speed. So I'm going to do a couple things. First of all, I'm going to do my update rate, and I'm going to change it to 1/2 second. And then I'm going to do my timing, and I'm going to make it times 1,000, so it's going to make it go 1,000 times faster than it does in real life. So now I can see that satellite ACTS going around the Earth. Alright, you have to have a few different types of satellites for your lab today, and this one, if I click on the satellite position here, I can see that the period of the satellite is 24 hours up in that box in the left hand corner. You may not be able to see that in the video, but it has a period of 24 hours, which tells me that that is a geosynchronous satellite because its period matches the period of the Earth spinning on its axis. Okay. Also up in this box I can see the altitude of the, there we go, so I can see the altitude of the satellite, I can see the period, I can see latitude, longitude, and speed. What we are going to be doing for your lab today is you're going to watch that altitude, and you're going to be able to find both a minimum and a maximum value for the altitude. And so what you're going to have to do for that satellite is you're going to write down its period, its minimum altitude, and its maximum altitude. The period you'll read straight off the screen there, and then the altitude you'll have to watch it as it goes around and find that smallest number as the minimum and the biggest number as the maximum. Okay? You also have to have a few other types of satellites. So that was an example of a geosynchronous because its period was about 24 hours. You will also have to have one called a low orbit. One example of a low orbit is this satellite here called Midori. I know you guys can't read the screen very well. So if I pull this around and I look at the Midori satellite, it's easy to tell it's low orbit. It's very close to the surface of the Earth. And for this one I can zoom in a few times to get a better view of it. Alright, so there's my Midori satellite, and I can see that that one's low orbit. So some of your satellites have to be low orbit, so make sure you find a few of those. Now as you can see, this one's moving really, really fast. So for my options, I can change that timing from times 1,000 to times 100. And that's going to be make it easier for me to track that satellite. Once again, go into view, satellite position, and then I can see those altitudes and the period that I need for my data table. Okay. Another type of satellite you have to have is a noticeably eccentric satellite. That's one that's very obviously elliptical. The two we've looked at so far are pretty close to perfect circles. Okay, an example of a noticeably eccentric one is this phase 3b. And the way you find these noticeably eccentric ones is you just click on them and then you look at the orbit. Okay, so if I look at the orbit of this one, I'll zoom out. and I can see that's definitely not anything close to a circle. That's definitely elliptical with the Earth at 1 focus. Okay. Once again, I'd get the period of the satellite, the minimum altitude, and the maximum altitude. And then the last type of satellite you have to find is you have to use some GPS satellites. Those are the easiest ones to find, because if you go down to the place where you pick the satellites, they are actually going to be named GPS something. Okay, so any of those GPS, BIIA, whatever number, those are all GPS satellites. Okay. So if I pick one of those, once again I can rotate my orbit. Once again I can go to View, Satellite Position. And you'll notice for the GPS satellites, they'll be close to circular. And you'll notice the period's going to be pretty close to 12 hours on those as well. Alright. So, eventually what you'll end up with for your data table is you'll need the name of the satellite, you'll need the period of the satellite, the maximum altitude, the minimum altitude, and then the orbit type, which will be either GPS, noticeably eccentric, low orbit, or geosynchronous. And if you check right here in step 10, you have to have a certain number of each type, so make sure you do that. Once you've got all your data, you'll be converting your period into seconds. You'll be using your Hmax and Hmin to determine the length of the semi-major axis. So then you'll have your period and your semi-major axis length. And then finally, you will figure out how to graph that in order to make a slope equal to the mass of the Earth. And you'll make that graph in Excel, because these numbers are very hard to hand graph. Okay? So give that a try today. Next time we're back at school, if you have some things you had trouble figuring out, you can ask a few questions. And then you can finish that up and get it turned in. Good luck. Go ahead and get this done before the snow comes this afternoon, so you can go out and enjoy that this afternoon. And we'll see you guys hopefully tomorrow, but maybe not till Friday.